Okay, so today we're going to be looking at Chapter 2-2 and 3, Part B. And this is where we're going to talk about multi-step equations and a couple of real-life type application problems. So first we need to talk about when we're solving an equation, how do we know what to do first? Okay, well, we use our dear friend PEMDAS. We use the order of operations to help us make these decisions. But if we're solving an equation, we're going to be doing PEMDAS backwards. So we're going to start with the A and the S, and then move our way to multiplication and division, and continue to undo. Okay? Now the reason we go backwards is because we're trying to undo each operation that's being done to the variable. We're trying to pull backwards each little piece until we find what we started with. Okay, so what we want to think about here is when is it that we use PEMDAS and when is it that we use PEMDAS backwards. PEMDAS is for an expression, when you're simplifying something. PEMDAS backwards is for an equation, when you're solving something. So in this situation here, we would be doing PEMDAS normal. In this situation here, we would be doing PEMDAS backwards. So let's look at an example. It says solve 2q plus 11 equals 3. So we're going to undo each operation that was done to q backwards through PEMDAS. So I'm starting with the addition and subtraction. So that means I need to deal with the 11 first. So the opposite of adding 11 is subtracting 11. That gives me 2q equals 3 minus 11 is negative 8. Now I can deal with the multiplication that I have here. The opposite of multiplying is dividing. And that gives me q equals negative 4. Now remember to check this. You will take the negative 4 and plug it in as q. To check to see that this is correct, I'm doing PEMDAS normal. I'm doing 2 times negative 4, which is negative 8, plus 11, which equals 3. So yes, it did work. Alright, let's try the second example. Again, backwards through PEMDAS. You should actually try this one on your own. You should push pause. Alright, so solving it, we're going backwards through PEMDAS. We're trying to see what's been done to the v. So the first thing we're going to do is undo addition or subtraction by subtracting 7 from both sides. So 6v equals negative 12. Now we deal with the multiplication by doing the opposite operation, which is division. So v equals negative 2. Alright, next example. This says k plus 9 divided by 12. This is a special case here. Remember that when it's set up like a fraction here, the stuff on top is inside parentheses. Where does p happen in PEMDAS? Right there. And so remember, we're going backwards through PEMDAS. So the first thing we come to is actually division. So we're going to undo division. The opposite of dividing by 12 is multiplying by 12. So we're going to multiply both sides by 12. That gives us k plus 9 equals 10. Oh, nope, multiplying, not adding. K plus 9 equals negative 24. Now we can deal with the addition or subtraction. Subtract 9 from both sides. And so k equals negative 33. right? Negative 24 minus 9. Yep, okay. All right, why don't you try letter D on your own? Push pause and give it a try. All right, so we're going to multiply both sides by a negative 6, because everything on top is in parentheses, so we can't touch it yet. That makes the negative 6 disappear. I'm left with negative 4j minus negative 4 equals negative 6 times 12 is 72. Alright, so I'm trying to get the j alone. I've got some multiplication and I've got some subtraction. What do I do first? Backwards through PEMDAS. I'm looking at the addition or subtraction first. I'm going to keep change this to make it a little less messy. Now I can see that that's a plus 4. The opposite of plus 4 is minus 4. That gives me negative 4j equals negative 76. And now I need to do the division, the multiplication division. Divide both sides by a negative 4. And that gives me that j equals a positive 19. And remember, we can check this by plugging it back in as j. Negative 4 times 19 plus 4 divided by negative 6 should give us a positive 12. Alright, let's look at some more examples. These get a little bit more complicated here. Let's try the one on the right first. This one will be a little bit easier. Let's start with easy. So the first thing I see is that I have more than one x. So before I can even do PEMDAS backwards, I need to combine like terms. I need to simplify this as much as I can before I do PEMDAS backwards. So I can do that math without solving the equation, just simplifying. 4x minus 8x is negative 4x. Now I'm going to solve. The opposite of multiplication is division, so I'm going to divide both sides by a negative 4. X equals negative 4. Final answer. Let's try the left side. Okay, in this example, again, I see I have multiple p's. So the first thing I want to do is simplify each side by itself. So I'm going to look at just the left side and I'm going to simplify it. I can combine 4p and minus p. That gives me 3p minus 11 equals, looking at just the right side, I'm going to simplify it. That 2 and that negative 20 can be combined. That gives me negative 18 and 2p. So I've simplified each side all by itself. Now I still have p's, more than one p, but they're on different sides of the equation. So because they are on different sides of the equation, I have to do the opposite operation to move it to the other side. So I'm going to subtract 2p from both sides. That makes this one disappear, and this one becomes 1p. The minus 11 is still there. The minus 18 is still there. Now that 1 is not very important. 1 times p is p, so that can disappear. Now all I have to do is solve for p. The opposite of subtracting 11 is adding 11. And so p equals negative 7. Alright, you're doing really well. The last thing I want to talk to you about is this concept of consecutive integers. A consecutive integer is a number right in a row. So 2, 3, 4, 5, they're consecutive integers. Negative 3, negative 2, negative 1, those are consecutive integers. 101, 102, 103, those are consecutive integers. Consecutive even integers would be like 2, 4, 6, 8, or 102, 104, 106, 14, 16, 18, 20, 22. Those are consecutive even integers. So how could we write consecutive integers using variables? Let's start with just consecutive integers, not fancy even ones or odd ones. Consecutive integers using a variable. So the first integer is going to be x. What is the next integer going to be? Well, if you look at the relationship between the first and the second integer each time, you notice that it's one more. We're just adding one more. So the second integer can be written as x plus 1. Look at the relationship between the first number and the second number. Excuse me, the third number. We're adding 2 between the first number and the third number. We're adding 2 between the first number and the third number. We're adding 2. So the third consecutive integer is plus 2. You can take the same concept and continue it. The first to the fourth is plus 3. So consecutive integers go up by 1 each time. How are consecutive even integers different? Well, again, we want the first number to be the variable, x. Then how is the first number related to the second number? We've gone up 2. So the second number is x plus 2. How about the first number related to the third number? It's up 4. So x plus 4. How about the first number to the fourth number? Plus 6. So it's x plus 6. So these are normal consecutive numbers, and these are even consecutive numbers. What do you think about odd? How would those look? Odd numbers, for example, 1, 3, 5, 7, what do those go up by each time? They go up by 2. So even and odd consecutive integers will follow the exact same pattern. Okay, so let's look at an example. Write an equation for the problem below, then solve the equation and answer the problem. Find 3 consecutive odd integers whose sum is 57. Okay, so consecutive integers, remember, in order for them to be odd, they will go up by 2, and they're telling us that I want 3 consecutive. So I got 1, 2, 3. And their sum, so I'm going to add them all together, is equal to 57. Alright, so can I solve this equation? You betcha. Combine like terms. I got 1x plus 1x plus 1x. That gives me 3x. I've got 2 and 4. That gives me 6. And all I have to do is solve that equation. Subtract 6 from both sides. That gives me 3x equals 51. Divide both sides by 3. X equals 17. That's the first number. The next number would be plus 2 more. So 19 plus 2 more, 21. And if you add those 3 numbers up, you will find that the answer is 51. Alright, so your practice tonight is on MyMathLab. You need to make sure you show all of your work in your notebook, and you need to get a 90% to get full credit on this assignment. If you have any questions, ask.